Hello, everyone. Let us talk about another in-class exercise. So for this one, we are discussing the very famous Linda problem to discuss probability rules. So we are given the following information. We are told that there is a woman named Linda who is 31 years old. She's single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. And we are asked to say, which of the following two statements is more likely? 1, Linda is a bank teller. Linda is a bank teller and a feminist. Now, given the information that we are given about Linda, this problem is designed to trick you into saying that this is the most likely scenario. But at the same time, it is a wonderful opportunity for us to practice what we just learned about probability rules, because what you can see here is that here we are asked to get a rough estimate of the probability of this single statement or this single event being true. So we have here P of A. But in here, we have a joint event. So in here, we would be asked to think in terms of the probability of both the event A, Linda is a bank teller, which is contained also here, and Linda is a feminist. So what we know about computing joint probabilities? Let's think about the product rule. So first off, we don't really know whether A and B are independent. We don't really know if there is any relationship between being a bank teller and being a feminist. So we're going to use the general product rule. And by that, we say that P, A, and B should be equivalent to multiplying P of A times P of B given A, right? This is the general product rule. And here, without going any further, we should already be able to tell that this is necessarily going to be smaller than the marginal probability that Linda is a bank teller. Why is that? Well, because we know that all probabilities are numbers that live between 0 and 1, even if they are conditional probabilities. Regardless of the fact that this is a conditional probability, this should also be a number that lives in between the range 0 and 1, similar to P of A. And therefore, I know that, this is a mathematical fact. Here, by multiplying whatever P of A is by another, I'm going to necessarily get at something lower. Therefore, we conclude that the probability of any joint event is going to be smaller than the probability of its marginal elements alone. And that is the solution to this problem.